Hello friends, welcome to my channel. Today I will share what I learned about the VDB nodes in geometry nodes in Blender 4.0. There's, to be honest, a bunch of nodes to learn, but also they are very useful, so I think it's worth to learn them. And if you have dived into these nodes before, you will find that Blender developer platform for their articles about these nodes, they introduced what is the VDB. There is some concept about grid and voxel and some usable node system, how to use them, like there are VDB modeling. If you are interested, I will put the link below. And today what I will share is based on my own experience, and I will introduce them like following the sequence of the nodes in Blender software. And first, let's talk about the concept of VDB in Blender. So you can see there are monkey head here, and there are cubes here. I just like instance these cubes on the VDB. Like there is a cube here, and I turn it into VDB, and I instanced like many cubes on it. So this will make it very easier for you to understand what is like the grid. Like there are many grids, and you can also understand that by this image provided by Blender website. You can see there are small cubes. They are the grid, and the grid contains information like density, like velocity, temperature, and information about the flame, like that. There is a much smaller concept is the voxel. The grid is made of voxel, and if you want to make like a very detailed effect, you need to turn the grid into voxel by some nodes. I will introduce the nodes in this video. So you can see here, these cubes means it's a grid that contains the information. If we want to define the number of a grid, you need to have x, y, z, 3 dimensions. Like index node, we define the number of index in a geometry. We use like integer 1, 2, 0, 1, 2, 3. But in VDB grid, we will need to define it like 0, 0, 0, 0, 0, 1, like that. So x, y, z, 3 directions. So after that, I listed some nodes here, like there is a sequence like in Blender. You can see there is a volume here, and there is read, sample, write, operation, and primitive. So I follow this sequence and list all of the nodes here. And you can see here there are some nodes that isn't listed in the sequence. They are like somewhere in the node system, but they are also related to the VDB, to the grid. So I listed them here. So I will follow the sequence here to introduce them one by one. So first we can see the primitive, the volume cube. If we preview it, you can see, let me check, missing output. We need output here. So we preview that it's just a VDB cube. It contains the information of density and the background. Like I changed the density, changed the background, it didn't work. I don't know why. It should work. So you can tweak this if you want. It's very simple. And next we will learn these nodes. There's like change the mesh to grid. So I will pour a mesh here. It's a monkey. So you can see there are SDF grid and the density grid and the volume. The volume, you must be very familiar with that. It has existed for a long time. So if we link the monkey head to here and preview it, it turns it into a monkey head. there's the volume here. So I disconnected this, and these three nodes are new. So first I will check a match to SDF grid. So you can see, if I turn the voxel down, maybe it's not very easy for you to see that. I like bandwidth to 5, bandwidth, more bandwidth. You can see a monkey head inside. Because SDF is like based on there is a distance system. This is the SDF grid is like especially for modeling, and you can see this. And if you link to point, you can see this. So here I will introduce a node like turn the grid into mesh to. So I use this grid to mesh to for better understanding of these nodes. So this is like based on the. So I preview this. You can see there are many points. So the face has more points, and like on the back of the head there are less points. So this points to SDF grid. It means it turned every point here into grid. So if I preview it, you can see every point is turned into grid. And if I connect the mesh to SDF grid, so it will turn this mesh into grid. You can tweak the voxel if you want. So SDF grid is especially for modeling. And here is mesh to density grid. You can link it and preview it. It will be like this. It's not for modeling. So the function of this SDF grid and the density grid is very different. The density grid contains the information of density. So these are the 4 nodes. We will use them in the following introduction. And next we can see like get named grid information and voxel index. Like if I build a volume cube here, it has a density information. So I can use the get named grid here, and I preview it. So you can see a volume, and if you check the grid, you can see nothing because we didn't define what attribute we want to get. So here we choose density. So we get the density and we get the volume. So let's check this. Grid input, group input. Preview it. So you can see there is a flame here. So if I connect it to volume and preview it, so it can preview the density, velocity, because the velocity has XYZ3 value. So it corresponds with RGB, so it has color, and the flame, and the shadow, and the temperature, like this. It will get the attribute inside the VDB and put it into a grid. And next is grid information. So with these nodes, you can get the information of the grid. Like if you connect the grid here, you can get the transport information and the background value. So transport is a metric. Background value is like the minimum value of this this like the minimum value in the grid. If you put if you have the density value, so the minimum value of the density, like for this, the minimum density is 0. And here we can get to the voxel index. It's similar to this as I introduced in the beginning. So it has 3 value, 3 dimension. So next we will go to sample. Sample is a very important node, sample grid. So at here, I use group input. Maybe not this, maybe just a volume cube. And I get the attribute of preview this. I need to first preview this attribute of density. Then I can like recast this density on a geometry. So we can use sample grid. No. Sample grid. So we have like sampled the density. We can't see anything because we have, we need a geometry to like show it. So first we need, yeah, and the geometry maybe, I think grid is good. So grid will make it bigger, and here is the grid, and here is the sampled attribute. So you can see it didn't work because we connected the wrong socket with grid to grid. So you can see the information here. So it means it doesn't have enough subdivision. So here I will give it a bigger value like 30. You can see. So if I turn to 100, you can see inside it's 1, outside it's 0, and like in between there are like numbers like this. So I need to turn off the attribute text. So this is sample. So with this method, you can like do a lot of things. After we sampled that value, we can have like this 4 nodes. So from this chart, you can see that gradient will turn scalar field into a vector, and the curve is the vorticity. Like it will turn like the velocity into vorticity, and divergence is like describe field expansion or compression, and Laplacian is about smoothness. So you can try them, and here, like I will show you how to use them. Like I think this volume cube is not very suitable for demonstration here. I will use grid input. If I use this, I can choose like here, many. So I can see where it's here, and you can see this is Flyn's density. I think, yeah, the Flyn's density. So here we have this like black and white. So here is the gradient, grid gradient. We can connect the grid here. It will turn it into gradient as I talk about like this. This is the gradient. If you spread the particles here, it can move the particles to make like some kind of effect, like my last tutorial. And if you want to, like the reflection, you can try that, what effect it will make. You just connect here and connect it to grid. It will be like this. So you can try. And let me check. If you want to use these two nodes, you need like a three-dimensional value. So here we have velocity. It's just crashed and I started again. So we disconnect this and turn into vector and we choose the velocity. So we have like a 3D dimension attribute. So connected to, like first we check the row effect, like turn into vector. Row effect is like this. No, here. And it's a vector like this. So normally we don't want the row effect. We want it like much complicated effect. So we turn the velocity into a voxel vorticity effect, and change that you can have this. It's like you can try that, spread some points in this space, and you can see the effect. And if you want to check this, if you can check this effect, greater divergence, you can connect here. And like sample, it needed to be a float. Connect here. It's like this. So you can try to use then what effect you will have. So they are used here. These 4 nodes. Okay. And here we have sample grid index and advect grid. So this node, advect grid, it means it can like add 2 attribute field, 2 attribute grid together to make a new grid. Like if here I will connect this to here. No. Into float, preview, into density. So I have a grid here, and like you can connect the velocity here. Yeah, it will be like this. If you like, let's try add a curve here. It will be like this. So, and let's try. If we add a gradient here, it will be like this. So you can just try. Okay, that's great. It didn't crash. So you can try to use them to make different effects. Just try. After that, we have a right. So store name attribute, set background, and set grid transform. So let's talk about these 3 nodes. These 3 are very simple. Okay, delete them. So we have a volume cube here. And that's named grid. So we have a grid, like I preview this. We can choose the density, and we have a cube here. And we use output nodes. Group output here. And let's check if they are, delete this one. Let's check if we want to output the grid. output the grid. Like we can see nothing. We can't output the grid. So this node here, you link the grid here, and you have VDB here. So it can turn the grid, the grid, because the grid is like the combination of the attribute. It's not a VDB, so it can turn this attribute into VDB and output it. So then you can render this VDB. So you can't render the grid. So this is where we use this store named grid. And for the set background, let me check if turn the density lower and set background. Like it didn't work. So sometimes it worked. It's a bit, yeah. It's a flame and connect. So here, I get the density. So here, so this is like smoke simulation. So the background is like the minimum. I get the density attribute for this grid. So this background is like the minimum value of this density. Like now it's 0. So the transparent part is 0. So if I turn it into 1, so normally all of them needed to be like it should be a 4 cube, but I don't know why it's like this. But it's you can understand this. It's a minimum value in the density. If you increase it, it's like all of them turn into like 26. And set grid transform it's like much easier to understand. So if you link it, it will be bigger like this. I don't know why. I didn't change anything. So there is a transform here. We talked about this. It like here it will output the transform and the background value. The grid inform. So background value is set by this node, and the transform value is set by this node. So we can combine metric or combine transform. Use these two nodes or other nodes. You can make calculations. So if you tweak the numbers, it will correspond with your action. So rotation, scale, anything, you can just change it. Very simple. And here we go to operation. This is about normally about modeling. So we have let me copy that. So grid to mesh and volume to mesh. And this is very easy to understand, like a volume cube. If I connect this to this, here is a volume cube. If I turn the volume into mesh, it will be like this. And like if you only have the density, you can't turn the density grid into mesh. So we need a grid to mesh here. You turn it into a mesh. So they are similar, but used in different circumstances. And then we will go to SDF Boolean, and there are these nodes. So you can see SDF grid is especially designed for modeling, as we talked about that we have a tube here. Like Blender use this to show you how to use that. So I will recreate this this scenario. Use transform this cube, this cylinder, like this. I think, yeah. So I use the mesh to SDF grid. It must be SDF grid. Connect them. You can see. Copy it here. Connect them. There is a cylinder inside. So then I use grid to mesh. Preview that. So the cube is like this. So we need a lower voxel, like 0.1. Yeah, that's better. And for the cylinder, yeah, smaller voxel. Yeah, that's better. So now we need to use SDF green boolean to like combine them together. It has 3 modes: intersection, union, and difference. So I connect them. This is the difference. Like if I change the position of the cylinder, yeah, you can see this is the boolean difference, and the union connected. Yeah, this is the union. This is the intersection. So you can try them by yourself. And there are some nodes here. Put it this way. So this one is simple offset. You can see. I will use uniform. Yeah. Yeah, offset. And this expansion. Yeah, this is the contraction. So after that, we talk about these nodes. They are all about smooth but different effect. If you can link the first grid fillet, you can see it's like this. If we try the grid reflection, it will be like this. So you can decide which one you prefer on different occasions. They are very different. Here, like this. Yeah, here, like this. Yeah. Very simple. And then we have the field to grid and voxel. So field to grid, I think okay, I deleted. There is no system. My Blender crashed because I lost that system. So I will rebuild this system. So I will build a system here. Choose density, yeah. And now I use the field to grid here. So it has nothing. So this node, like we can use some attribute like a noise or other attribute. You can define some certain attribute to affect the grid system. So here I use noise. Connect this. And I think I need to use the ramp here. Let's check it. So now I think it's not very easy to see that. As we know, grid is created by attribute inside, so I think we can use the next node here. We can use the multiply to add the attribute. It will be like this. So let's check before. Before it's like a cube, and after we use noise, it's like this. So this is what this node is for. You can use like other attribute to affect the grid system. So for voxel lines and prune, so as we talked about in the beginning, so grid is like a very like a rough level, and the voxel is very detailed level, and the smallest element is the voxel. So you want to make like a many very detailed effect, you need to use the voxel to voxelize the grid to release the full performance. So like this. You added that, it will be like this. And I change the scale. So it looks like this. And Peru is like the invert voxelize. If you I have connected them. If you turn the value into 1, so it return into the grid mode. If I turn to 0, it turns into the voxelized mode. So sometimes you want to save computer performance, you can use these nodes to do something. And I think I finished all the introduction. I think the VDB nodes updated in Blender 5.0 is like a very big update. There's a lot of nodes to learn. So I think this tutorial is helpful, and I hope you like it. So this is all about today's tutorial. Thank you for watching. Bye bye.